So take a look at the special dates here. I'm going to go over this with you. This is important. We're getting to the end of the 9 weeks. I'm going to tell you all the last possible grades in this class, ways to pull your grade up or down, right? So we always have 2 tests per grading period. We've only had 1 so far, and so we have another one coming up, and we'll talk about that. We also have 1 last quiz, and that's 1.12. So that's today and tomorrow's stuff. It's online on College Board. A lot of my quizzes are online, which means you can work with people, which means you can use your notes, okay? Our quiz grades haven't been excellent lately. So think about, opening it on Friday, which I know you guys don't want to do a quiz on Saturday or Sunday, whatever. You find when it works for you in the next week. But maybe think about sitting down with somebody to do it, making sure you have really good notes. And I'm going to be pointing out some specific places in today's and tomorrow's notes where I'm going to be like, you're going to have a question like that on the quiz, or you're going to have a question like that on the quiz. So maybe you can star it or something so you know to go back at that, when you're not taking the quiz. So that's that's your last quiz. Let me talk about SAT in a second. Your last homework check is next Wednesday or Thursday. I had it decided, but I figured if I put it on the earlier day, it just benefits you if it's one day later. Okay, so your last homework check will be next Wednesday or Thursday. And then our last test, okay, so first of all, let me go back up to school-wide PSAT. SAT, 9th, 10th, and 11th graders are taking the PSAT, and seniors will be taking the SAT, the whole school. So if you're here, you're testing. There'll be signs around the school to tell you where to go, and it's on your laptop. Okay, so you need to make sure you bring your laptop, charger, all that stuff. That's Tuesday. So we lose that day. And as you know, we lost 3 days last week, and only one of them's getting made up at this point. And usually, if we miss 2 days in a school year, they just let us miss those 2 days. It's fine. But now that we've hit 3 days, they're having us make it up on October 14th. So October 14th is not this coming up Monday. It's the next Monday. We were supposed to have no school that day, but now we do. And those 2 days, Monday and Tuesday, are the days of our next test. Even though next Friday ends quarter 1, officially it's over next Friday, our test is going to be Monday and Tuesday, and it's going on the first 9 weeks, okay? I try my hardest to never have assessments on Mondays. I don't like to do that to you because I just know it's hard to be prepared on a Monday. You're doing your own life on the weekends. But this time it was unavoidable because of all the days that we missed and being the end of the grading period. So please understand, I try really hard not to have tests on Mondays, but it is. And it's a 2-day test. Yes, Evan. Mm-hmm.
And also after
what I'll do is I'll put it over there on the cart, so before you leave, if you want to take a picture of it, that's fine. He was asking about the review. Yes, we are going to review next Thursday and Friday. Next Thursday and Friday, I will create a review that's just like the test, just like the last test. Remember, I didn't lie to you. Your review and your test were the same except for numbers. I'm going to do the same for this test. It'll be graded on a curve like always. Traditionally, my test grades are very high because of that reasoning, because of the curve. Okay, so don't let that stress you out. I would be more focused on getting that quiz grade up. If you look at how I weight my grades, tests are a category, quizzes are a category, and homework is a category. Your lowest overall, students' overall lowest is in the quiz category. We still have people forgetting to do quizzes, not doing them at all. So they get a 0. And then if they didn't do great on another one, only one of them gets dropped. So let's make that last quiz really count. You have a whole week to do it. You can work on it and leave. You don't have to submit it. It'll save your work. And then hit submit when you're done. But even if you forget to submit, it will always submit for you. When it closes, it automatically submits it. So feel free to go in and out of it as much as you need to. You know, you're sitting with somebody in another class. Oh, can you help me with this problem? Whatever, okay? And I'm going to do an extra credit next week. If you remember, the pink sheets are extra credit in this class. So I've been telling you, I haven't talked about it in a while, but at the beginning of the year, I talked a lot about keeping your pink sheets in the front of your binder. I made them pink for a reason, to help you identify them. And I don't use pink for any other worksheets or anything. So if it's pink, it should be in the front of your binder. And the way you get extra credit is literally, I will just say, okay, I'm doing extra credit right now. Everybody open your binders. Okay, do you have the course at a glance sheet? And I literally, if you have it, you don't have to do anything. You just have to have it. If you have it, you get extra credit. Okay, the formula sheet, the course at a glance, the calculator tips, the factoring steps. I think that's all we have there. If you're missing any of them, because they ripped out, you lost them, whatever, you can find them on Canvas under the very first module we did. It says Unit 1, blah, 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 and the pink sheets. They're all in there. It does not mean you have to have them printed on pink paper. I don't care what color they are, okay? I just make them pink for you so it stands out for you. But if you need to print one on white paper, that's fine too. You do you. It's fine, okay? And, oh, what I was going to say is I'm going to put the pink sheet, extra credit, in the quiz category, okay? Putting it in the homework category doesn't really do much for you. Even if you have a low homework grade, homework's only 10% of your grade, okay? But, so this time I'm telling you I'm going to put it in the category under quizzes, so that's going to help the quiz category grade, all right? But you still have one more to do. Any other questions before we start? Okay, pretty short notes, very short homework, probably will finish in class. A lot of what we're going to talk about today is going to be what you learned in Algebra 2 and Algebra 1 and geometry. It's something we do all the time. What changes, so a lot of times when we do stuff from your past math classes, it's a review, but we might add a little to it, and that's the case here. And for us in this lesson, it's really about the vocab and how we answer the questions, okay? So I'll explain that as we go. So what we're doing in this section is transformations of functions. The word transformation means change. So how we change a function, whether we're looking at the graph and we change it, we're looking at the function in equation form and change it, or we're looking at a table of values and we change it. There's basically 4 types of transformations, and they're listed here for you, okay? The one we don't really do in algebra-based classes is rotation. You might remember rotations in geometry, like when you had to rotate a shape like 270 degrees around the x-axis or, you know, over the x-axis around the origin. We don't do rotations. So what we do in this class is focus on 3 types, which is dilation, reflection, translation, okay? So we have to know what these words mean and what they do to the graph. And I'm going to go over all of that, okay? So under the umbrella term of transformations, we have those 3 types, okay? And then within that, there's basically another 2 categories, and that's rigid and, you'll see on the next page, non-rigid. So we'll talk about rigid and non-rigid. This is one of the questions on your quiz. There's a question that asks, is this a rigid or a non-rigid? So you're going to have to know that. So what rigid transformations are is they keep the original shape and size of the graph unchanged. So it's like if you took a parabola, so think of like a U, like a smiley face, and you shift it, translate it up, down, left, right, it moves around the graph, but it doesn't change the shape, the size. If you flip it, it doesn't change the size, okay? So I'll go over all of these right here, but rigid means this original shape and size doesn't change. It just moves around the graph, okay? So these first 4 are called translations. Okay, so you can see the word translation in there. Translations move your graph up, down, left, right. Up, down, left, right. And it's we can tell that in a function by wherever, well, let's do vertical first. Okay, let me back up. The word vertical affects what part of an ordered pair? Verticals, tell me, verticals up and down. So what part of the ordered pair gives us the up or down? The y. So anytime we're talking about something that happens to a y, we're going to use the word vertical. Okay, we're not going to say up or down. We're going to say vertical. Okay, vertical is up and down. And translation means up or down. That's what that means, or left and right. But in this case, up or down. And it's always this k value that's at the very end of the function. What's really nice about transformations is everything I'm talking about today applies to every single function we do in math. It applies to lines, parabolas, cubics, quartics, radicals, logs, trig functions even, sine, cosine, all that stuff. So it's the same stuff you've probably heard a million times. So you can always find the k value at the end of whatever the function is. It's not in parentheses or anything. It's just the last number. And if there isn't one, it's 0, okay? So the ordered pair would be, if we're going up, you would add to the y value. If you're going down, you subtract, right? Going up, you would add. Going down, you would subtract. Horizontal is left or right, and we can always find the horizontal h value in hanging out with x somewhere secluded, okay? Like in parentheses. Just remember, in function form, if this is written in an equation, you're not going to see the letter h or the letter k, you're going to see a number. So you have to know that if it's at the end, it's a k. If it's inside, it's an h. And it's not always in parentheses. It could be up in an exponent, it could be under a radical, but you will always know h because it's with his best friend, x, and they're always secluded off by themselves. They're somewhere private, okay? And so horizontal, of course, is going to affect your x values. And there's one more special thing you have to remember about horizontal translations. Does anybody remember? Minus goes to the right, positive goes to the left. It's opposite. So if you see minus, it means to the right. If you see positive, it means go to the left. Okay? And like we said, it's going to affect your x value. So if I see a minus there, I'm going to go to the right, which means add to my x value. And if I see a plus sign, that means go to the left. So going to the left would be to subtract. And we'll see all these in a minute. We'll practice with real numbers. Okay, so those are translations, a type of rigid transformation. Next type is the reflection. You might have called it a flip in other classes, which is fine, but we're going to call it a reflection now. You can reflect across an x-axis, or you can reflect across a y-axis. You can say across, you can say over. I've seen the word about. But we have to know what it looks like in function form and what it does to the ordered pair. So if you have a negative right after the equal sign, that is flipping over the x-axis. If you have a negative inside the parentheses, in that private little area, sequestered off, hanging out right next to the x, that is flipping over the y-axis. So let me just show you something. You already know that this is a parabola, right? There's my parabola. If I suddenly put a negative in front of it, what happens is it flips over, that's ugly, sorry, flips over the x-axis, right? So think about things you already know. You know this is a positive, this is a negative. What happened? It just reflected or flipped over the y-axis. Let's take that a step further. If I have a point in this quadrant, let's just call it 1, 1, 3. I'm just making up a point. If I flip it over the x-axis, what would the ordered pair be? 1, negative 3. So when you flip over the x-axis, the y value sign changes, okay? I am not good at memorizing anything. I just don't, I can't. Old, tired, whatever. And so, you know, it's like, oh, there's a negative after the equal sign. That means it flips over the x-axis, but that affects the y's. It's a lot. X, y, flip, negative, where, what, huh? So whenever you get to a point where you're like, I can't remember if I changed the value of or changed the x or changed the y sign, think of something you know where you can find it in your brain. All of you know how to graph this point. That's to the right up. That's positive 1, 3. How would I get to this point? To the right 1, so the x didn't change, but going down, they should be lined up. Going down would have meant negative 3. Let's also think about flipping over the y-axis. If I take this point right here and I flip it over the x-axis, think about what that ordered pair would be. Instead of positive 1, it would be negative 1. Does the y value change? No, we're still at positive 3. So when you flip over the y-axis, the x changes its sign. Okay? If you're good at memorizing, great. But, you know, you guys are busy. You've got lots of teachers giving you lots of stuff, and all these tests, you have to remember so much stuff. So if you can't memorize, which I actually hate that word, understand it. If you understand what it means to reflect, think about that point and what happened in the ordered pair. Okay, that will help. Those are all your rigid transformations. They're called translations or reflections. Okay? So we're not going to do these problems, but I want you guys to understand this notation. There's a lot of, here's a function, now make these changes to it and get me a new function. Okay? So, for example, g of x is going, so I'm going to say this in like a paragraph form. G of x, the graph of g of x, the function g of x, is the function of f of x moved down 5. So for example, this is f of x. If I wanted to find g of x, I would just take all my points and move them down 5, right? So this is saying g of x is the graph of f of x, all the points moved where? Right 3. So I would just take graph of f of x, move, like literally go 1, 2, 3, 1, 2, 3, 1, 2, 3, move all the points to right 3. And move all the points right 3. And that would give you your translated graph, okay? So there is a question on your quiz like this where it does it just like this, and it's all multiple choice, and you have to match which one of the choices, A, B, C, or D, has the graph, that same graph, moved down 5 places. So you just have to count which one, okay? Or right 3, or whatever it may be, okay? So just being able to read that and tell, right? So there's another question on the quiz. Rigid, non-rigid, match the graph to what transformation is going on. There might be more than one of those. All right, let's move on to non-rigid. Non-rigid is the same shape, but it's going to change the size of it. And we've called those stretches and shrinks. Think about a parabola. You can stretch it, it makes it taller and skinnier, or compress or shrink it. It like pushes it down, makes it like fatter, all right? We're not going to worry about stretch or shrink. We don't even use those words really anymore. I mean, it's not wrong to, as long as you also call it a dilation, okay? Dilations mean, in the old school, old classes, stretching and shrinking, okay? And today, we're only going to talk about vertical dilations because horizontal is tomorrow. I'm not a fan of the way her notes are, so I'm doing my own thing. So just understand, we're going to save this for tomorrow. We'll talk about that tomorrow. But let's just talk about the vertical dilations. Vertical dilations make your graph taller or shorter. It takes all those points and stretches them. If you're doing something to make it go taller or shorter, which of course means vertical, what would that affect, the x or the y values? Y values. If you're going to make a graph taller, that's going to change the y value, okay? And we'll see that. And what we do in that ordered pair is we multiply the y value by what? I forgot to go over that. The a value. A can be found right after the equal sign, okay? So you might have y equals 2x squared plus 5. That's a dilation, vertical dilation. And we're going to do these with actual numbers in a minute. No one thought that. I actually heard someone say that's the easiest lesson we've had all year from someone last period. So when I get to actual examples, you'll see what I mean. But right now, just have everything in your paper, on your paper. And so we used to care a lot about if A is greater than 1, we call it a stretch. If A is less than 1, we call it a shrink. We don't need to say those words anymore. We use this term, dilation. Dilation. Okay, so today we're only worried about the vertical dilation. All right, so let's look at our first example here. It's telling us the domain of f of x is this, and the range of f of x is this, okay? What they want us to find is the domain and range of h of x if we do these transformations to f of x. So let me translate that for you. So what we're given, so I'm just wanting to make this nice and clear. I'm given the domain and the range of some function f of x. I don't have the graph. I don't have the table of values. I don't have the equation. I just know whatever f of x is, its x values go from -6 to 8. Who cares what happens in between? That's all we know. That's all we care about. And the range, so the y values of this f of x function are -3 to 7. Okay, so that's given to us. What they're asking for is domain and range. Oops, I keep writing G, it's H of x. What is the, sorry about that. Oh, it's going to bug me. The domain and range of h of x. Okay, so let's see what they gave us. H of x is the f of x function with these 3 transformations done to it. So what we're going to do is it's called a rule. We're going to come up with a rule that will change these numbers according to this, okay? Really, really simple. Really, really simple. You have to look at this function and say, there are some numbers in here that affect the x values. There are some numbers in there that affect the y values. So anything that affects the x values, I'm going to do to the domain. Anything that affects the y values, I would do to just the range. And the easiest thing in the world, listen, anything that is in the parentheses, nowhere else. If you're in the parentheses, you are going to be done to the domain. That affects the x values. Anything on the outside of the parentheses affects the y values. It's that simple. Okay, you don't have to go back through the notes and think about it. It's just knowing in parentheses affects x, outside affects y. I mean, you do have to do a little more than that because now we're going to go to the rule. What are we going to do to our domain, aka our x values? Well, the only thing that is going to affect the x values is this x plus 1. We know that that moves all the points left 1. Mathematically, is that adding 1 or subtracting 1? If we go to the left, if I'm on the x-axis and I'm at 5, and I want to go left 1, where do I end up? I end up here, right? I would go left 1, so that's subtract 1, okay? So I'm going to take my x values and subtract 1. That's the rule. That's what this is telling me to do. All my x values, I'll subtract 1. We'll come back to that. Let's do the range rule. Remember, if you're on the outside of the parentheses, you affect the y values. So the 2 is a vertical dilation. We just learned about that, okay? And what you do is you multiply the y by 2. So we're going to have 2 times our y value. That's this. And then what is that minus 3 going to do to that? What does minus 3 on the graph do? Yeah. So if I'm at, I don't know, if I'm at 5 and I go down 3, I'd be at 4, 3, I'd be at 2. What math was that? Did I multiply by something? What did I do? Subtracted. That's what I'm looking for. You subtract 3. Remember, that k value is not opposite. If it's plus, you go up or add. If it's negative, you go down or subtract. It's inside that's opposite. So that's left 1 or subtract 1. Right? And look, guys, all we're going to do is that math. So I'm going to take my 2 x values, -6 minus 1 and 8 minus 1. So my new domain would be from -7 to 7. I just shifted all my x values left 1. Okay? I'm going to do the same thing for my y values. 2 times -3 minus 3. That would be -6 minus 3, which is -9. And, whoops, not 2. Yes, 2 times 7 minus 3. So that's 14 minus 3, which is 11. So my new range would be negative 9 to 11. Okay? So this would be our answer. This was given. This is the answer. Okay? And we're going to practice that in our homework together. Okay? Let's do a couple of these. There is a question just like this on the quiz, for sure, where you're given a table of values. Okay? It's really important that you should be able to look at this and tell me what this is. This is a bunch of ordered pairs. These are my x values. These are my y values, right? K of x means y. And they apply to the function whose name is k of x. Okay? So this is k of x's information. What is it saying? Let's find some information about h of x if we do this. Oh, wait, I forgot. I'm saving this for tomorrow. Sorry, I forgot. This has that, it has the thing I'm skipping, the horizontal dilation. So that's one of the other things we're going to save. So anything that has to do with a horizontal dilation, which you haven't learned yet, told you there and here, saving for tomorrow. Sorry. Yay, we get to skip it for now. But we'll go over it tomorrow. Last thing, this is also what your homework is. This is exactly like your homework. 5 and 6 are these two problems. But this is really important. At the beginning of class, I talked a little bit about how, I think you guys are remembering left, right, up, down, even the stretches and shrinks, like dilations you might remember, like in the Algebra 2 language. But here's where we're going to really practice saying in words, writing in words, what the transformations do to the graph using our varsity math language, okay? We are not going to graph. So same thing for number 5 and 6 in your homework. You don't have to do the graph, okay? We're just going to list in any order, by the way, the transformations. So let's look. Here's f of x. F of x is x squared. G of x is, we're going to do these 3 transformations to f of x to get our new function called g of x. So there's 3 numbers, 3 transformations, 3 things, so 3 transformations. And in any order, let's list them. So let me kind of help you guys with this first one. This 2, back in Algebra 2, you might have said stretch by 2. And it is, but that's not enough for this class. So what we would call it is a vertical, and you can abbreviate, vertical dilation. And you might see by factor of 2 or just by 2. So we have to identify that that number after the equal sign dilates the graph vertically. You have to say that. Okay? So that's the 2. Now, back in Algebra 2, you might have just said left 3, which it is. It does move the graph left 3. Let's put it in varsity math language. Left or right, that's horizontal, right? So instead of saying left or right, we're going to say horizontal. Be careful how you abbreviate this word. You get it? All right, horizontal what? Is it a reflection? Is it a dilation? Is it a translation? And you can start abbreviating if not to, trans or whatever. Okay, horizontal translation. Two different ways you could say it. Pick one. You don't have to do both. You can do horizontal translation of -3, because it's opposite, or you could say left 3. As long as you already called it a horizontal translation, it's fine to say left 3. Okay? Either one. You don't have to say both. And then last one would be this one. You're going down 4, right? That's down 4. Now we will call it vertical translation. And again, you can say of -4, or you could have said down 4. Okay? So this, really the new part of this is just using the correct language. Last one, then we'll go to the homework. There's 4 things going on here. Let me tell you something that's really important. Dilations will never be negative. Never. So in Example A, it was just 2. In example B, it's just 1/2. You will never say a vertical dilation by -1/2. What does the negative actually mean? Negative means reflect. Remember, if there's a negative right after the equal sign, remember my beautiful picture? If you have a negative, it flips it over the x-axis, okay? We're going to use the word reflect. Reflect over x-axis. If you just said reflect, not enough information, because you can go over the x or the y. So that takes care of the negative. The 1/2 is a vertical dilation by 1/2. Remember, you will never have a negative dilation. It's just positive 1/2. Right 3, right? That's what we would normally say. Right 3, we're going to say right is horizontal. Translation by 3 or right 3. I don't know why I keep picking up another pen. Okay. And then the last one is up 1. That up means vertical. Trans by 1, or you could say up 1. So have to be able to say those words. And that's what number 5 and 6 are. So what we're going to do is go to the homework, and I'm going to have you work on 5 and 6 on your own for a minute. Check your answers, ask questions. Then I'll do number 9 with you. Okay? So homework is on page 130. Write it down if you have it. And the order you write them in does not matter. I think I've said that enough times that you guys get it. Just a couple minutes, guys, on 5 and 6, because then I'm going to jump in and do number 9 with you. I'd be quick, so I'm going to do number 9 in a minute. I'd be quick, so I'm going to do number 9 in a minute. Caitlin, all right. On what number? Nope. A vertical dilation, we'd need a number after the equal sign. There isn't. I mean, I guess it does, but if you multiply something by 1, it doesn't change it. You wouldn't write it. All right, guys, listen. Shh. I'm going to go to number 9 right now. You want to go to number 9 with me. It's very easy, but you need me to explain it, okay? Very, very, very easy. So even if you're not on number 9, skip number 9. I'll put the whole key back up again, okay? All right. In number 9, so understand, it's each of the table values line. Okay, I'm not going to read that. We are going to come up with ordered pairs for g of x, given ordered pairs for f of x. Think about what we have. These are ordered pairs of f of x. What we are trying to find is ordered pairs for g of x when we do these transformations, okay? So we're going to come up with a rule. Remember, we're going to change x values by anything in the parentheses, y values by anything on the outside. So I'm going to take all these x values and I'm going to do what to them according to this x plus 3. Subtract 3. Remember, it's always opposite because we're going left, right? Don't forget that. It's 100% of the time, you're always going to do the opposite. So all my x's, I'm going to subtract 3, okay? Which means I'm going to take each of these x values, right here, it's just a nice, little chart to organize our work and everything, which is going to give me a new x value over here. -3 minus 3, my new x value will be -6. When I move -3 to the left 3, it will be now on -6, and so on. So that took care of my x values. Remember, anything on the outside of the parentheses affect the y values. That negative in front is going to flip it over the x-axis, but it does affect the y value. Remember, above or below the x-axis affects the y value. And we're going to go down 4. So flipping over the y just changes the sign of the y. So if you were at +1, now you're at -1. Or if you're at -1, you're at +1. And then down 4. So whenever you have a negative in front of something, it means the opposite. So take the sign and change it. So if you're a positive, you become negative. That would be -5 minus 4. -3 minus 4. You can't change a 0 sign. Instead of -2, you'll have +2. Change the sign, subtract 4, and that will give you your y values. Ready? Yes, because it's a flip. Okay, so that right there, change sign of y value. It's on that first page. Let's come up with the rule together for the other two, and then you can just fill in the charts and be done. So again, anything in the parentheses, change the x. On the outside, changes the y. So what are we going to do to all of our x values according to this? Add 1, because we're going right 1. That's what that means. Anything on the outside applies to the y values. So we're going to go up 3, right? That's what that means. And stretch or dilation by 2. So anytime we're doing a dilation, it's multiplication. So it's 2 times my y values plus 3. So then you'll do that. And then let's do the last rule together. Then I'll put all the keys up. You can ask me for help if you have it. Last one. Anything in the parentheses affects the x's. That is right 3. If we go to the right, we are adding. Anything on the outside of the parentheses affects the y's. So we have a dilation, that's multiplying. and also going up would be plus 1, right? So then you just use your calculator or your brain and find those values. It's not hard, but there's a lot of little things you have to remember. So don't just copy the key. You're not going to learn if you just copy the key.